Good morning to all. Today we are going to discuss about the Lorentz theorem and Lorentz series. If f of z is analytic in the ring-shaped region R bounded by two concentric circles C and C1, radius R and R1, here R greater than R1 and with center at A, then for all z in belongs to R, f of z equal to summation a n z minus a whole power n, summation a minus n z minus a whole power minus n. So here one function is given, that function is f of z. This is analytic in the region. That region is ring-shaped region. This ring-shaped region is bounded by the two concentric circles. Two concentric circles means same center, different radius. Here we are taking the two concentric circles C and C1, radius R and R1. Here R is greater than R1 with center at A. Observe here, we are taking the two circles. One outer circle is C, inner circle is C1. Outer circle radius is R, inner circle radius is R1 with center A. So if you observe these two circles, we have the common region. This is the common region. This common region look like say ring shaped. So the given function is analytic in this ring shaped region. Okay. Now we need to find f of z value as summation a n z minus a whole power n, summation a minus n z minus a whole power minus n. Observe the first term, expand by substituting n equal to 0, 1, 2, 3, then a naught, a1 z minus a2 z minus a whole square and so on. That means first term contains positive powers. Observe the second term, substituting n equal to 1, 2, 3, expanding a minus 1, z minus a whole power minus 1, plus a minus 2, z minus a whole power minus 2, and so on. That means second term contains negative powers. That means Lorentz series contains positive powers and negative powers. If you observe the previous Taylor series contains only the positive powers. That means we can represent, suppose if you represent the given function in terms of the only positive powers, that is called the Taylor series. In terms of the positive and negative, that is called a Lorentz series. Here an and minus an are quotients. These two are defined by the integral. An is 1 by 2 pi integral f of w by w minus a whole power n plus 1 dw, where n equal to 0, 1, 2 and so on. A minus n equal to 1 by 2 pi integral f of w by w minus a whole power minus n plus 1 dw, n equal to 1, 2, 3 and so on. Observe the problem. Let's look at the problem. Find the Lorentz series expansion of the function f of z equal to z square minus 6z minus 1 by z minus 1, z minus 3, z plus 2 in the region 3 less than z plus 2 less than 5. That means in this region, we need to find the Lorentz series expansion of the given function. First, use the partial fractions procedure, separate this value. So here 1, 3, minus 2 are the real and non-repeated roots. The corresponding partial fractions are a by z minus 1, b by z minus 3, c by z plus 2. Now taking LCM and cancel denominator part, then find that value is z square minus 6z minus 1 equal to a into z minus 3, z plus 2, b into z minus 1, z plus 2, c into z minus 1, z minus 3. Now substituting z equal to 1, 3, minus 2 in this expression, we get the ABC values. Substituting z equal to 1 here, then this part becomes minus 6, this entire part becomes minus 6a, so a equal to 1. Substituting z equal to 3, first term and last term 0, middle of the term exists, 3 minus 1, 2, 3 plus 2, 5, 5 into 2, 10b. Here this side substituting z equal to 3, that will be minus 10. So b equal to minus 1. Next substituting z equal to minus 2. First two terms are 0, only last term exists, minus 2, minus 1, minus 3, minus 2, minus 3, minus 5. So minus 3 into minus 5, minus 15. Minus into minus plus 15. 15 c equal to this side 15. So c equal to 1. Substituting a, b, c values here. Then 1 by z minus 1, minus 1 by z minus 3, 1 by z plus 2. Now we have to expand this function in this region. If you observe the region, this region contains z plus 2. That means we need to express this function in powers of z plus 2. Let us take the substitution as z plus 2. So here z plus 2 equal to w, z equal to w minus 2. Okay, take the region 3 less than z plus 2 less than 5. Substituting w value 3 less than w less than 5. In this, we are going to use the binomial expansions, but the binomial expansion is possible for less than one case only. So make every region is less than one form. So this is divided into two categories. One is 3 less than w, other one is w less than 5. So here 3 less than w, taking the reciprocal. If you take the reciprocal or multiplying the minus, then only the sign will be changed. Greater than becomes less than becomes greater than. But remaining all cases, same sign exists. So 3 less than 5. Taking the reciprocal of 3 is 1 by 3. Reciprocal of w is 1 by w. This less than becomes greater than. So multiplying both sides by 3, then here 1 greater than 3 by w. Write reverse form 3 by w less than 1. Next, w less than 5. So dividing both sides by 5, w by 5 less than 1. So we have to change the terms as 3 by w form and w by 5 form. Here w minus 3 is exist. We can make this value as a 3 by w form, taking w common 1 minus 3 by w. Here w minus 5 exists. Here we are taking the minus 5 common 1 minus w by 5. Shifting to numerator, apply binomial expansion. This is of the form 1 minus z whole power minus 1 form. 1 minus z whole power minus 1 is 1 plus z square and so on. In place of z, 1 by w exists. Sorry, 3 by w exists. So 1 plus 3 by w plus 3 by w whole square and so on. Here also same thing. In place of z, w by 5 exists. 1 plus w by 5 plus w by 5 whole square and so on. Finally, substitute w value. W is z plus 2. So this entire value is converted to powers of z plus 2. Here this first part contains the negative powers. Second part contains the positive powers. This is required Laurent series expansion. Next, let f of z equal to 1 by 1 minus z minus 2. Okay, function is given. We need to find Maclaurin series expansion of f of z. Maclaurin series means what? We have to find at the point 0 case. And Laurent series expansion in the analyzed region 1 less than z less than 2. Analyzed region is nothing but a ring shaped region. And Laurent series expansion in z greater than 2. First bit is Maclaurin series means what? It is nothing but a Taylor series, only positive powers exist. But second and third bit Laurent series means positive and negative terms are exist. So take the function value resolving into partial fractions. That value will be 1 by z minus 1 minus 1 by z minus 2. We want to expand by using Maclaurin series. So in this case, 0 case, we are finding the Maclaurin series. That means Maclaurin series is possible z less than 1 case only. Z less than 1 means what? Z by 2 is half of the value is also less than 1 only. Take z minus 1, z minus 2. Okay, so here taking minus common, z minus 1 becomes 1 minus z. In this case, taking the minus 2 common, term becomes z by 2. Okay, use binomial expansions. 1 minus z whole power minus 1. 1 plus z square and so on. 1 minus z by 2 whole power minus 1. Same formula, but in place of z, taking z by 2. 1 plus z by 2 plus z by 2 whole square and so on. Multiplying by minus. This expression contains only positive powers of z. This is required Maclaurin series expansion. Next, second bit, Laurent series expansion in 1 less than z less than 2. So in this case, we are taking the region 1 less than z less than 2 region. In this region, we have to expand the given function in Laurent series. Make these two values as a less than 1 form. 1 less than z represented as z greater than 1. Taking reciprocal, z reciprocal is 1 by z, 1 by 1 is 1, greater than becomes less than. So 1 by z less than 1. Here z less than 2. Dividing both sides by 2, z by 2 less than 1. Now here make one of the term as a 1 by z form and other term as z by 2 form by taking the values z are constant values common. So in this case we are taking the z value common 1 minus 1 by z. Here we are taking minus 2 common 1 minus 2 by z, 1 minus z by 2. So apply binomial expansion. In place of z we have 1 by z and z by 2. So here 1 plus 1 by z plus 1 by z square and so on. Here 1 plus z by 2 whole square and so on. So this term contains the negative powers, this term contains the positive powers. So total series contains both positive and negative powers. So this is the required Laurent series expansion. Next, we need to expand Laurent series expansion for z greater than 2. Z greater than 2 means what? Automatically z is also greater than 1. Taking the reciprocal, that is 1 by z less than 1 by 2. Z greater than 1. Taking the reciprocal, that will be 1 by z less than 1. Multiplying both sides by 2. So 1 by z less than 1. Multiplying both sides by 2, 2 by z is less than 1. So make one of the term is 2 by z and the other term is 1 by z. In this first term, we are taking z common. So one of the term is 1 by z form. Taking the z common again, here also that will be 2 by z form. Now, expanding using binomial expansion. So 1 plus 1 by z plus 1 by z square and so on. Here 1 plus 2 by z plus 2 by z whole square and so on. Observe here first term contains the negative terms and second term also contains negative terms. That means this series contains only the negative terms. Given series contains only negative terms or positive or negative terms, that series is called a Laurent series. So this is required Laurent series. Next, expand f of z equal to 1 by z square minus 3z plus 2 in the region 0 less than z minus 1 less than 1, 1 less than z less than 2. So take the given function, find the roots. Roots are 2 and 1, resolving into partial fractions. That is 1 by z minus 2 minus z minus 1. Take the first region 0 less than z minus 1 less than 1. So in this region, we have to expand the given function. So let us take the substitution. Z minus 1 equal to W, Z equal to 1 plus W. So substituting here, then what? 1 by W minus 1, 1 by W. So taking the minus common, apply binomial expansion. So 1 plus W square and so on, minus 1 by W. So substituting W value, that is Z minus 1. This is required expansion. Next, take the region 1 less than z less than 2. So 1 less than z less than 2. So divide into two cases, 1 less than z and z less than 2. So taking the reciprocal. So this is divided into two cases, 1 less than z and z less than 2. So make this value is less than 1. That is 1 by z less than 1. Dividing by 2, z by 2 less than 1. Taking here minus 2 common, here z common. Apply binomial expansion. 1 plus z by 2, z square by 2 square and so on. Here 1 by z square and so on. So in this case, this term contains positive powers. This term contains the negative power. So this is required Laurent series expansion.